All right, so this is going to be, we ran out of film, so this will be the next one, whatever the next one is, okay? Now, this is going to be 23 point what?
25.4.
25.4? And this is going to be,
38.
what is it?
38.1.
38.1. Okay, are we okay with that?
Yeah.
All right, yes? Okay. So let's erase this. Sodium, sulfur, oxygen, okay. Now here's another problem. This is sodium, this is sulfur, and this is oxygen. Here's another problem. You're given an elemental analysis, and your elemental analysis says that you have a white powder, okay, which is made of 36.5% sodium, 25.4% sulfur, and 38.1% oxygen. Yes? And they say that they know what the molecular weight is. They can come up with a molecular weight, and they say that it's 252. Okay? Yes? All right. They want to know what's the empirical formula and what's the molecular formula, even though it's not a molecular formula. I'm making that up. Okay? I'm making that up. So, because it's an ionic compound. So, what's the empirical formula given this material? Well, let's base it on how many grams. If I base it on how many grams, don't I know how many grams of each I need? I have? Come on, guys. You're here, right? How many grams? What am I going to base it on? Percent. How many grams am I going to base it on? How many grams of the material do I have? What's convenient? 100. Thank you. 100 grams. If I have 100 grams, don't I have 36.5 grams of this? What's 36.5% of 100? 36.5, right? Okay. So, I have 36.5 grams of sodium. I have 25.4%, I'm writing percent, grams of sulfur. And I have 38.1 grams of oxygen. Right? Let's write that a little lower. 38.1 grams of oxygen. Okay? Now, what is going to, the first thing you do is you got to break this down. I can't compare grams. I cannot compare this many grams of oxygen and come up with any kind of idea that I have. I can compare that with sulfur. But what can I compare? If I know how many oxygens there are, then I can compare that with how many particles of sulfur I have. So what am I going to change that to? What am I going to change the grams to in order to have a more even comparison? All right, let's work through this. 23. I want to change it to moles, right? And when you do that, I'm just suggesting do 4 significant figures. I'm just throwing that out there. Okay? So what is, I want to know the moles of each. I want to know within 4 significant figures. 1 point 587. Is that okay? That's 4. Okay, good. What's this one? 25.4 divided by 32.
0.794.
0.794.
No, sorry. 793.8.
793.8. Yeah, that 0 that you put before that some people do, came out in the new math in the 1960s. That's actually not a significant figure. What's the next one? 38.1. 2.381. Is that correct? All right, good. Now what you do is, now you come up and you do your ratios. Make up 3 ratios, okay? Large over small, large over medium, and then medium over small. Those are going to be your 3 ratios, okay? So this is going to be, what's the largest one? Oxygen, right? So oxygen over what? Small. Sulfur, which is going to be what? 2.381 over 0.7938, right? Then you gotta come up with a ratio, okay? Now, bring it out to hundredths place. Just saying, just do hundredths place. All right, now, largest over medium. 2.3, so it's going to be what? Oxygen over what?
Sodium.
Good, thank you. Oxygen over sodium. And that's going to be what? 2.381 over 1.587. And then medium over small is going to be
Sodium over sulfur.
sodium over sulfur. That's going to be 1.587 over 0.7938. All right, so what do you get?
For the first one,
Yes,
for largest and first ones, you get 2.99, 2.999.
what is it?
99.
2.99? Okay, good. Yes?
All 3. It's 3.
3 nines.
3 nines? I said hundredths place, but
Okay,
If it's 100 place, then it would be 3.
then it would be 3. Okay, good. Good, excellent. Okay? What about, right? Because it's large to small, so it's 3 to 1, right? Right? So it's oxygen over sulfur, right? What about the largest over smallest?
1.5.
1.5 to 1, and that's going to be what? Oxygen to sodium, right? What about the next one? Medium to small.
2.
What is it?
Just 2.
Just 2? Remember, it's 2 over 1. That's important. And that's going to be what? Sodium over sulfur. Correct? Are you okay with that? Right? Now, you need whole number ratios. Can you use 1.5?
No.
No.
Round it up to 2?
No, you can't. You can't round it up to 2. I'm not laughing at you. I'm just...
Yeah. Round it down to 1.
No, you can't do that either, really, because it's 1.5 to 1. Wouldn't that seriously distort the amount of oxygen I need for nitrogen? So I need 1.5 to 1. So what do you think you'd do?
Three to 2?
Yeah, very good. Well done. Well done. 3 to 2. Yeah. Okay. So now you're ready. Now you set up your elements from left to right. What goes on the far left? You have 1 metal and 2 nonmetals. What's going to go on the far left?
Metal?
Always. What's going to go on the far right? Always.
There are 2.
Oxygen.
So sulfur goes in the middle.
There you go. Right now, what's the ratio? Well, let's see. Sulfur to oxygen is 3 to 1. right? Oxygen to nitrogen, oxygen to sodium is going to be 3 to 2, right?
Yeah, and that works for sulfur as well.
And that works for sulfur as well. Now, what's the empirical formula weight? Remember? What's the empirical formula weight?
252?
No. What was the formula weight? What was it? Wasn't it 126?
Yeah, it was.
Right? So, this is the empirical formula. And the way you write, a way of writing the empirical formula is just to write the lowest ratio, obviously. That's the empirical formula. But you'd say, okay, right. Can I erase some of this now? You'd say, where n represents a multiple. And that multiple is molecular weight over empirical weight equals n. So 256 divided by 126 equals 2. So the multiple is 2. So that means Na4S2O6. Correct? Now, obviously, that's nonsense.
Wait, over electronic weight, or what was the E again?
Empirical weight.
Thank you.
Empirical formula weight. Okay? You all right with that? Now, this is nonsense, right? This is nonsense. But it just tells you a story, right? For instance, let's say that, what's 13 times 6? 78. Okay, yeah, that's the classic. All right, so let's say I find my empirical formula to be that. I have a hydrocarbon, and I find the empirical formula to be that. Okay? And I find that the molecular weight equals 78. Correct? Mm-hmm. Right? And I find, what's the empirical formula weight? What's that?
What is the empirical formula weight?
The weight of the empirical formula.
Okay.
It's a formula weight. In other words, here, look at this.
So it's 7. Should be 7.
65.
What's that called? Is that a molecule? No, it's not a molecule. Molecule's covalent bonding. I said that, right? That's a formula unit. It's a formula unit. I know, weird, huh? So some people call it empirical formula weight. Some people call it the formula weight. All kinds of things you're going to find out there in chemistry. So what's the formula weight? CH. Can you add 12 plus 1? 13. 12, 1, 13, right? So remember our little
6.
molecular weight over empirical formula weight equals N. So it's going to be 78 over 13 equals N. N equals 6. So what's our molecular formula?
6.
What is it?
6.
Benzene. Benzene. Classic.
Is the molecular weight going to be provided, or how do we find it?
No, the molecular weight would have to be provided.
Okay, I got it.
Would have to be provided. You okay?
What about the 12? The atomic mass? No, the atomic number. Are they going to tell us?
You have a periodic table, right? The mass number is what you're asking me, right? The atomic number would be 6 for carbon, but you didn't mean that. You meant the mass number. Like, what's the mass number of carbon? Like, in other words, how'd you get 13, Portia? Is that what you asked me?
Yeah.
you're going to have a data book. I'm going to provide you with one. Yes? Now, I'm going to turn this off, okay? And then let's just talk about the exam for just a minute, okay? All right?